Okay, folks, you are coming to my door right now, so this is kind of funny. Um, we are learning about lesson 8.8 today. It's called the difference of squares. It's us identifying another pattern in our factoring that will help us to make this a little bit easier, a little bit quicker for us to be able to factor trinomials. All right, so when we check this out, I guess this will be factoring binomials. If we check out our pattern here, it's called difference of two squares. It's called that because it's you finding the difference of two squares. So here's a square, a squared, and the difference because it's subtracting, and b squared. So that means that when I do the math, when I FOIL it, I can just take the square root of the first one, the square root of the second one, and I'm going to separate by a plus or a minus, or a plus and a minus. So for example, g to the second minus 49 turns into a g plus 7 and a g minus 7 because g times g makes a g squared, and because this is a difference of squares, a 7 times 7, a negative 7 makes a negative 49. Now those inner terms, when we were to FOIL, they get canceled out, so they don't get written down because they make a 0 g's when we're all said and done here. Alright, so with that pattern, we're going to start with our examples. So our very first example here, we have a 16x to the second minus 81y to the second. These are both perfect squares. So the square root of the first number here is going to be a 4x, and then the square root of our second number is going to be either a positive 9y or a negative 9y. So it doesn't really matter. So we'll have a 9y. So we chose the positive first time, and then we'll have the same exact pattern for our second term, or our second binomial. So again, we're just breaking this down into the square roots of both of these numbers, and then we're separating something plus, something minus. Okay? So that should be a pretty easy thing for us to identify. Now, just like before in example 2, our job is to, again, step 1, look to find if there's a GCF. Now, because this problem has a GCF that we can take out, we are going to do that. So we're going to pull out a 3b, and then we'll be left with a b to the second and a minus 9. Now this part right here is our difference of squares. So this turns into our two situations. So we'll bring down our 3b, and that's going to get multiplied by a b plus 3 and a b minus 3. Now it's a b because it's the square root of a b squared, and it's a 3 because it's a square root of a 9. Now, because those were perfect squares. So that's officially our answer then. All right, moving forward, we'll do the exact same thing. Now we have an x to the fourth power. This is a perfect square. We have a 625. I believe that's a perfect square. Let me grab a calculator real quick just to prove to myself that it is. Let's see, the square root of 625. Perfect, that's exactly what I thought, but I wanted to double check to make sure I don't make any stupid mistakes on video because it's on the YouTube. So we're going to break our two numbers down. So we have an x to the fourth power. That turns into an x to the second. And because it's a difference of squares, we have 1 plus, we have 1 minus. It does not matter what order those are in. And the square root of 625 is 25. I just double checked on the old calculator just to prove it. So then this officially is not my answer yet, because right here we can identify another difference of squares. So this part comes straight down. We're going to have an x squared plus 25. And then we break the other difference of squares further. So this becomes an x plus 5 because the square root of x and the square root of a 25, and an x minus 5. So then our official long answer is 3 binomials. And again, this only works for a difference, so that means the problems have to be a subtraction problem. Now when you do Euro question 1, make sure you keep track of what we did on example 3 for that being able to help you out. Now your question 2, I want you to remember that you're looking for a GCF and then you're breaking things down. The problem, I had to change it just to make sure that it worked out for us. I had the wrong numbers. So here we are. Again, we're going to look for the GCF first. So we can divide out of all four of our numbers a 6. When we take out the 6, we're left with an x to the third plus a 5x to the second minus a 4x and minus a 20. Now when we factor by grouping here, folks, looks like a 5, actually let's just do it like this. We can take out of both of these terms, we're going to have a x that we take out. So when we take out an x, we're left with an x to the second and a plus 5x. We should take out an x here. This should be just a regular x. My bad here, folks. We divide out an x to the second, and we're left with an x plus 5. Now over here, we're going to take out, because we're looking for this to be an x plus 5, again, we're going to divide out a negative 4, and we're going to be left with an x plus 5. Now again, we have a 6 that's being multiplied by all of this stuff on the outside. So we combine these two together, so that's going to make an x squared minus 4, the 6 on the outside, and an x plus 5. Now our job here, folks, is we have to identify that we have an x squared minus 4. That's a difference of squares, so that's going to break down even further. So we're going to have a 6 on the outside times an x, square root of x, square root of 4, plus 2, and an x minus 2. And this guy was all by itself, so it just comes straight down, and it's an x plus 5. Now this is officially what our answer is. Now folks, we have one more problem here, but I'm going to ask that we try this one, and we'll take care of it during class when you return. Do your best. I'm going to guess that you might have a little bit of troubles, but again, we'll do this one in class. So thank you very much for paying attention. We will get back at you guys when you come to class again. See ya.